Hello everyone, my name is Ashutosh Pandey and my USN is 1BI22CS002 and my topic is accessing IO devices. So today I'm going to talk about accessing how to access IO devices and some basic concepts of IO devices and what they are. IO devices just stands for input and output devices. So let's start with the topic. So there are types of IO devices and methods to access them. So, so basically, what IO devices are, it's input and output devices. These are the devices which are used to interact with users and the computers. So they can be categorized into two types, basically input and output devices. So input devices are the devices which takes the signal or data from the user and store them in the computer and process them. So the basic examples of those input devices are such as keyboards, mouses, touch screens. So keyboard takes the text and commands from the users and then sends them to the computer devices and for CPU, the processor. And then mouse takes moves the cursor and selects the items, and then there's touch screen. Touch screen is used to interact with the computer and the user uh, through touch. And then there is joystick as well. Joystick it's used for input as well. It's also an input device. And then there is output devices. Output devices are used to receive data from the computer and display it to the user. So there are monitors. Monitor displays the visual output for the user to see and to interact with how the things are going on and to see what's going on in the system. Then there is printers. Printer prints the documents that and images, and then speakers. We listen to music with the speakers. Then there are projectors. Projectors are used inside for in lecture halls and classes and a lot of homes to watch movies and all. So it gives a visual output. It's like a monitor, but monitor is on the screen, and but the disc is on a bigger screen. So let's go on the next topic, and that is computer networking basics. So the basic things that you have to know, like about is computer networking. So the computer networking devices that are connect and share information and resources. That's what we call computer networking. Common types of computer networking, including LAN, WAN. There are more, but LAN and WAN are the most basics that you have to know to process them. So LAN. So LAN is a network that connects devices within a limited area. So limited area such as home or office, it allows easy sharing of files, printers, and internet access. So LAN is a very small, is on a very small level, and it connects a lot of devices together in a small area. Then there is WAN. WAN is a wide area network. That's what we call WAN. And LAN is local area network. But WAN is for wider range. The span is larger area and it connects with a multiple LANs together. It enables communication between geographical dispersed locations such as different offices or cities. It spans to a large network. It has a wider area range. It can be even cities. When large cities are connected with WAN itself. So this is one. There are a lot more as well. There is metropolitan area network. There are some more, but these two are the most basics that you have to know that we have to know for this topic. And so network security and best practices. So network security is essential to protect sensitive data and prevent unauthorized access. Implementing best practices can help safeguard your network. Security is very important when you're using something, when you're using an internet or network, when you're networking. Security is very important. So, use strong password and regularly update them. That's very important. Enable firewalls to monitor incoming and outgoing network traffic. So firewalls firewalls prevents from a lot of encryption and lots of it's for security purposes. That's what keep software and firmware up to date and patch security vulnerabilities. Encrypt sensitive data to ensure confidentiality. Huh. So you have to encrypt the data so it maintains your confidentiality so that no one can access your documents and all. And then there is regular backup data to prevent data loss. So you have to regularly back up your data so the data that you have doesn't get lost. So that was all for network security. These are the preventions you have to take for security. That's all. So our next topic is direct IO devices. So there are three types basically: simple implementation, synchronous communication, and prone to blocking. So let's start with synchronous communication. In synchronous communication, this method involves direct communication between the CPU and the input-output devices. It waits for the device to be ready before sending or receiving data. So, and simple implementation, the second point. Simple implementation is the direct input and output devices goes straightforward in access in straightforward method. Well, it is only suited for simple input devices, low level interactions, and it's not very complex. It's basic level. And for prone blocking, if an input output device is slow, it can block the CPU and halt the execution of other instructions. It can so programmed IO. So manual control, high CPU overhead, suitable for simple devices. So in this, let's start with manual control. Program IO involves the CPU manually transferring data between memory and input-output devices using programming instructions. And high CPU overhead, this method requires continuous monitoring by the CPU, resulting in high resource. But in this method requires continuous monitoring, like CPU continuously monitors, and but it also gives high resource usage. Suitable for simple devices, yeah. Program IO is effective for simple input-output devices and direct memory access, which is also called DMA. We'll learn about it later in later part. It's typically used for more complex operations. Yeah, it is used for more complex operations. Interrupt-driven input-output. So in interrupt-driven input-output, the CPU is not continuously involved in data transfer. Instead, IO devices send interrupt to the CPU when they require attention, minimizing CPU overhead, improving overall system performance. That was that's what interrupt-driven IO is. Interrupt. And then interrupt-driven IO devices. What are the advantages and limitations of that? So interrupt-driven IO devices offer several advantages, such as improved system performance, reduced CPU overhead. But however, they also have limitations, including potential bottlenecks and the need for efficient interrupt handling mechanism. Understanding these Understanding these trade-offs is crucial and for effective system design. Now, interrupt-driven IO. So what it contains? Like it has efficient resource utilization. With interrupt-driven IOs, the CPU is not in charge of continuous monitoring, allowing it to execute other tasks while waiting for an interrupt. And then there is enhanced system responsiveness. When the input and output device has data ready, it triggers an interrupt, enabling fast response without holding the CPU hostage. And then there is complex implementation. Interrupt-driven IO is more complex than programmed input-output, but it is essential for high-speed devices and systems with multiple IO devices. Next is DMA. That's what we said, like explained in the later part. Direct memory access allow and output devices to transfer data directly from memory without involving CPU. It doesn't involve CPU. Uh, this improves efficiency. This improves efficiency, reduces CPU overhead, and enables faster data transfer for high bandwidth devices. Okay. So that's what direct memory access is. It's self-explanatory with its name itself. And then there is device drivers. What are device drivers? Like their definition. So device driver are software that allows the operating system to communicate with hardware devices. And they are essential for enabling the system to control and manage output devices, input output devices. Now there are types of device drivers. Device drivers can be categorized as kernel mode and user mode, depending on the level of access to the core functionalities of the operating system. Now, interrupt handling. What is interrupt handling? We did discuss about this in the previous part, but it was not properly explained. So here I have explained properly for this. In interrupt handling. Interrupt handling is a crucial aspect of operating system. It's a crucial aspect of operating system that allows devices to request attention from CPU. When an interrupt occurs, the CPU suspends its current task and handles the interrupt request, ensuring efficient and timely device communication. Okay, so now we discussed about the device drivers. So there were two device drivers, kernel mode and user mode. So this is kernel mode. Kernel mode, it has direct access. So kernel mode is device driver that is which has direct uh, access to kernel. So allowing them to interact closely with the hardware and enhanced privileges. They have elevated privileges, enabling them to perform critical operations and handling system resources directly. Okay, because it's near to kernel, so the resources allocation is very easy and it can be allocated. The resources can be allocated directly. So now there is user mode device drivers. In user mode device drivers, they are restricted. They have restricted access. So user mode device drivers have limited access and operate in more isolated environment, ensuring system stability and system security. So it maintains system stability and security. So user level operation, they handle operation at a user level and rely on the kernel to access critical system resources and perform hardware interactions. So it's basically for user interaction itself. And then for conclusion, this was all in the topic. So not so big. It was not so deep as well. It was just a small topic for us to discuss. So, the conclusion that we got from this is IO devices have play a fundamental role in enhancing user experience. That we learned in the starting itself because. Without IO devices, you can't do anything in the computer system or in computer organization. You can't do anything without IO systems. So it enhances user experience, productivity, and the overall functionality of computer system. So without IO devices, input and output devices, you can't do anything in a computer or computer system. So as technology continues to advance, we can expect further innovations in IO devices and technology as we already have, and it's continuously improving as well, paving the way for even more immersive and interactive computer experience in the future. That's what everyone's hoping for, and that's why this topic is important that we should know what a computer system where IO devices are for more further development in the future. And the presentation has also provided a comprehensive overview of accessing input and output devices that we have learned in the entire topic in the computing system. Through this explanation, we have gained valuable insights into significance of IO devices and the methods used to interact with them efficiently. That's what all we did about in kernel and user mode level and everything. We did interrupt call, what are interrupt calls and what are uh, ev- what are the uh, what are interrupt calls and what are other functionalities that we learned. We have also learned that accessing IO device is essential for enabling communication between user and computer system, whether the input devices like keyboard, mics, or output devices like printers or projectors. These peripherals facilitates the exchange of data and information. That's what all output devices does. It shows us the information that the ALU or the CPU has processed, and then allowing users to manipulate digital contents. Then that's what our topic was completely actually, and that's all.